Welcome back to our C Sharp beginner tutorial. In the previous lesson, we looked at subclasses and overloaded members, and I just to review what we talked about in the previous class because there was one extra keyword we didn't look at. So we looked at virtual in the previous class. We looked at new keyword. That's the new keyword that you use together with members, not the one you use for constructing objects. And then we also looked at one more, what was that? Virtual new, let me check our program. I think there was one other, the override keyword. So we also looked at override. So there was one extra keyword, the abstract keyword, which I said we'll leave it till this lesson so that we will see. We can only see its effect when we use abstract classes. So in this lesson, we're going to look at abstract classes, and then we'll also look at abstract members. Okay, so I hope we still have, if you've forgotten what these three do, you should go back to the previous lesson and just take a quick review and come back, because to understand the abstract you have to kind of understand virtual, because there are similarities between abstract and virtual, and there's also a difference between them. So we'll see that when we go into Visual Studio. So in this lesson for today's lecture, we're going to have to create a new class entirely. So we're not going to be using our fire breathing dragon class. Should we create a new? Okay, there's no need to create a completely new solution. We can still use our subclasses basic solution and just add a new class. Okay, so first I'm going to create an abstract class. Okay, maybe before we go ahead and create an abstract class, we should give a brief definition of what an abstract class is. Okay, so abstract class. Okay, so an abstract class is like a class. Okay, it is a class. Actually, it's a class. However, an abstract class is a class that that cannot be used to create objects. Okay, remember when we did objects, we kept on saying in order to create objects we need a class. Okay, now that is one thing you need to know. For the abstract classes, you cannot create an object using an abstract class. I know one may begin to wonder now, then what is the whole essence of having an abstract class if you cannot create objects with it? Now, the use of abstract class is simply to allow you to extend the class. Okay, so suppose you have an abstract class called let's say we have an abstract class called AC. Okay, you cannot create objects of this AC. Okay, you cannot create objects of this class. But what you can do is you can extend AC, so you can create a class. Let's call it RC, short for the real class or something like that. So you can create a class RC, which is a subclass or an extension, okay, of AC. Okay, So you can create a class which is non-abstract, by the way. Okay, you can create a non-abstract class RC, which is a subclass of AC. Okay, and then by doing that, RC is going to inherit all the members of AC. Okay, remember what when you subclass. Okay, whenever you extend, by default, your subclass inherits all the members, all the methods, all the properties, all the fields of your base class. So that's the whole point of an abstract class. Okay, now the reason you would really want to have something like this is, imagine if you have um, a group of, or let's say a class of some category of things. Okay, and then those classes, suppose you have class A, class B, class C. Okay, let me just draw it out. You have class A. Okay, you have class B, and you have class C. Okay, these are three different classes. Okay, now A, B, and C share some things that are common. Okay, there are some things that are in A that you would like to be in B, and that you would also like to be in C. Okay, in that case, you would say, okay, why not just create a normal class and then just create subclasses of A, B, and C of them. But another thing you would want, okay, which is going to break the example I just gave you, why you would not just want to create a normal superclass, say normal superclass D, and so this superclass D is just a normal class, and then just create subclasses. I will show you why this would not be sufficient. Okay, now imagine if at the same time where you have things that are common in A, B, and C, you have some members inside A, B, and C which have the same signature, by the way, but you do not want their implementation to be exactly the same. Okay, you want their implementations to be different. Okay, but the members should actually have, they should be similar. Okay, maybe this example is too abstract. Okay, I can see the pun. No well, I didn't intend to make a pun there. Okay, let me give a better example, of a more practical example. Suppose you have an animal class. Okay, remember, all animals have some things in common. For example, they live. Okay, suppose you have a method live, or a method called eat, for example. Okay, so all animals have a method eat, and you realize their eat method should, like, they should all be the same across all different types of animals. Okay, they eat and they grow, and they eat and they grow. Okay, so all animals should have a similar eat method. Now, you animal could also have another method called speak, for example, speak. Now, you would realize that depending on the type of animal you are creating, the speak of, say, a cat is going to be different from the speak of a human. Okay, now okay, so what you have is, you have something like cat, you have something like dog, and you have something like human. Okay, now you realize that while eat is common to cat, dog, and human, they should be, we're assuming in our implementation, they should all be the same. Speak should be different. Okay, speak, the way the cat should speak should be different from the way the dog should speak, and it should also be different from the way human should speak. Okay, in addition to that, you will notice that there is no way you can just create an object of an animal. Okay, like, can you have an animal that is neither a cat nor a dog nor a human nor any other type of a species of animal? It doesn't really make sense. If you understand what I'm saying, okay. Suppose these are all the different types of animals you can have. Assuming, okay, these are all the sets of the different categories of animals. You realize that uh, um, if these are all the types of animals, then I've lost track of what I was trying to explain. I just got distracted. Let me try and remember. Okay, so we're talking about. Oh yeah, I wanted to bring you to a point. I remember now. You realize that you cannot create an object of an animal that is neither cat nor dog nor human. Now, we are assuming that these are all the different types of animals, okay? You realize that if it's not a human, it is not a dog, it is not a cat, then obviously it's not an animal. And also, if you say you want to create an animal, it has to be one of these, okay? Right? Now, remember, we're assuming that these are all the different types of animals. That lions, tigers, everything is somehow merged into this set. Okay, you realize that you cannot have an object of animal. Okay, so that is an indication that an animal should be an abstract class. Okay, you can have a class that is a subclass of animal which you can create an object of. Okay, so you can create an object of cat. Okay, but cat can only inherit from animal. Okay, cat can inherit from animal. Animal cannot create objects. Okay, so animal is an abstract class. Cat, dog, human are concrete classes or normal classes which are subclasses of animal. I hope this makes sense. Now let's go back. Let's go into Visual Studio, and I'll try to explain the abstract keyword, abstract classes, and abstract members, and we'll see it in action. Okay. All right. So we said we're going to create a new class. So I'm going to go to Project, Add Class. So you realize the way you create an abstract class is very similar to the way you create a normal class. So I'm just going to call this animal .cs, and I'll choose, remember I've already highlighted class, and I'll choose add. Okay, so here it just says class animal. I'm going to change that to public abstract, okay, class animal. And then in here we said we're going to create two methods. Okay, so first I'm going to have a public void eat, for example. So an animal has an eat method. Okay, so that's one thing you should notice. Even though you cannot create objects of an abstract class, an abstract class can have non-abstract members. Okay, that is something you should keep in mind. You can actually have non-abstract members inside an abstract class. So this is a non-abstract method. Okay, and we're going to say console dot write line. It's going to go num num num. Okay, so num num num. Okay, so that's for this method. Okay, now before I create the other method, I want us to create three different classes that are subclasses of this animal class. Okay, so we're going to go to project, add class. I'm going to create a human class. Okay, human, and I'll choose add. I'm going to make this public class human, and I'm going to say it extends animal. Okay, so it's a subhuman is a subclass of animal. I'm going to repeat the step, add another class. I'm going to create a cat class, cat, and I'll choose add. I'll say public class. Notice I'm not making them abstract classes. Okay, these are concrete classes, meaning we can create objects of these classes. So public class cat extends animal. Okay, and then one more class. I'm going to go to project, add class. Now choose dog, and I'll choose add, and I'll say public class dog extends animal. Okay, all right. So we have our three different classes: the cat, the human, and the dog. They are all subclasses of the animal class. Okay, now notice by default, okay, let's just go ahead and save this file, save all. Let's go to our program class. Let's get rid of or instead of getting rid of it, we could just comment them out. No, let's just get rid of, yeah, let's get rid of that. So what I want us to do is, we've created this abstract class, right? I just want to show you the way an abstract class works. Okay, so we've created this abstract class animal, and it has an animal can eat. Okay, and when we tell an animal to eat, it's going to go nom nom nom. Okay, irrespective of what type of animal it is. We're assuming that this eat method is common to all the different types of animals. Okay, so if we go to our program class, I'm going to create a cat. So I'm going to say cat, a cat. So this is the cat variable, or let me give it a name. Okay, let's just call it cat1. Cat1 is equal to new cat. Okay, and by doing this, notice what happens immediately. I can say cat1 dot eat. Okay, I can tell the cat to eat, because remember, it is a subclass of animal, and animal has an eat method. Okay, so immediately I create cat, that cat inherits the eat method of animal. Okay, you remember subclasses. Okay, so the same thing with the human. I'm going to create a human here. Human uh, uh, human1. By the way, you don't have to call your variables this way. You can give them actual names. Okay, we can say Dan, for example. Dan equals new human, and I can go ahead here and say, after cat.eat, I can say Dan.eat. So I can ask Dan to eat, and immediately it can eat. Okay, the human can eat, the cat can eat, because they are all subclasses of the animal class. And I'm going to create the last one, dog. Let's call him Bingo, and can say equals new dog, and we can go down here and say bingo dot eat. Okay, so bingo is just the name of the variable where we're storing the dog. Okay, it's like the identifier. Okay, so I'm going to file save all, and I want you to see what happens if we run this. Remember, we created a cat, we created a human, we created a dog, and then we call the eat method on each of those animals, and see what happens. They go nom 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 nom. Okay, they all call the same method in the animal class, this particular method. Okay, now this is because they share this eat method. everything about animals, the way animals eat is similar. Okay, they share. We're just giving an example here. Okay, there are cases in your programming where you want to create classes that share some things that are similar among across those classes. Okay, so you you carry out this kind of pattern. Okay, so they inherit from the same superclass. Okay, now if we go back to our program class, and then what I want us to do now is, imagine if we want to implement an eat method now for dog, for cat, and for human. Okay, we want them to have different eat methods, but we also have animal. We will also want animal to have that. Sorry, not eat. Speak method. We also want an animal to have that speak method. Okay, so if a dog can speak, a cat can speak, a human can speak, we want to be. We want to also say that an animal can speak, isn't it? So really what we're trying to achieve is, we want a speak method in this animal class. Okay, but what we want is, we don't want that speak method to be shared across the dog, the cat, the human. Okay, we don't want to individually create speak method. Okay, so what I mean is, I don't want to have to come in here into the human class, create its speak method, go to the cat class, create its different speak method, go to the dog class, create its different speak method, and then we're left with animal doesn't have a speak method. Okay, that's not what we want. Okay, we want a speak method in the animal class. Okay, but when the human wants to speak, we want the human class to implement its own speak method. Okay, so eventually we're still going to come into each classes and create different implementations of the speak method. Okay, but we want the original speak method to be in the animal class. Okay, I don't know if this makes sense. Now, to do that, what you need is actually an abstract method. Okay, so we're going to say public abstract void speak. Okay, and remember, for abstract methods, like I explained earlier, if you create abstract methods, what the method is saying, when you define a method as abstract, what it means is that you're saying the implementation, yes, you've created this method in this class, but the implementation of this method is left for whichever class inherits whichever class inherits it, is left with the responsibility of implementing the method. Okay, that's what the abstract keyword is means. Okay, is you would see when we use it, it's very similar to the virtual keyword. The only difference between the abstract method and the virtual method is that, you see, for virtual method, when you create a virtual method, you expect to override it. Okay, now it is not necessary for you to override that method. If you do not override the method, then the old one, okay, is going to be used. But for abstract methods, notice that they do not even have implementations. It's because you're saying it is compulsory for whichever class is going to inherit this method. It is compulsory for that class to implement this method or to override this method. Okay, the class that inherits this method, that class, it remains the responsibility for that class to override this method. So it is necessary for whichever class that's non-abstract, whichever non-abstract class inherits this method, it is mandatory for that class to provide concrete implementation of this method, that's to override this method. Okay, so we're going to see how we're going to do that in the human, the cat, and the dog class. So notice now that immediately after we added this abstract member, this abstract speak method, you can see that if you go to your human class, you can see now that your human is giving you a red underline, meaning that something is missing. Notice the error that is saying human does not implement inherited abstract member animal.speak. Okay, so that's what I just finished explaining now. Because human is a subclass of animal, it extends animal, it inherits that animal.speak, that speak method. So it is mandatory for human to implement that speak method. Okay, the same thing for the cat and the same thing for the dog. Okay, so we're going to go ahead and implement those methods. So to do that, you'll have to say public void. Okay, we have to mark it as override. Okay, public override void, and we say speak. Okay, and in here, okay, so don't worry when it writes this throw new not implemented exception. Just go ahead and erase that. Okay, and type in your implementation. We're going to say console dot write line woof woof woof. Okay, so that's how the dog speaks. Okay, so the dog goes woof woof woof, right? So this is the this is the speak method for the dog class. Okay, notice that you are mandated, you have to provide this speak method in the dog class. Unlike if this was a virtual method, then in that case you are not mandated to provide this speak method. Okay, that's the difference between virtual and abstract. Okay, I want you to see the difference. For abstract, you are mandated, you must override that method in the subclass. Okay, but for virtual, like we saw in the previous lesson, if you mark this method as virtual, you do not have to override it. Okay, you do not have to provide implementation for that method. Okay, you can choose to use whichever method. You can choose to use the virtual method. Okay, all right, just to finish, let's just go ahead and finish this. I'm going to go to the cat class. The cat class, we're going to provide the implementation. For the speak method, we're going to say public override void speak, and I'm going to remove all this, and I'm going to say console dot write line meow. Okay, all right, so that's the implementation of speak method for the cat class. Now for the human class, let's just complete that. I'm going to say public void public override. By the way, I don't know if you can write the void before the override. I'm not sure. Let's try that. Speak. Okay, so you can't do that. The override has to come before the void keyword. Okay, so we're going to say console dot write line just a bunch of gibberish. Okay, just a bunch of gibberish, because he forgot about because you forgot about it. Yeah, I mean, I will agree with that. Okay. So that's the implementation of the speak method in the human class. Okay. And okay, let's just go ahead and save this file, save all. And let's go to our program class now. So we have implementations of speak method, okay, in the dog, the cat, and the human. Okay. Now let's create okay, we've already done that. We've created a cat, we've created a human, we've created a dog. Now let's go ahead and call those methods. So cat1 dot speak, okay, and cat2 sorry, not cat2, dan dot speak, and bingo dot speak. Okay. Okay, now if we run this method, if we run this program, we'll see what happens. What's going on? Why is it taking so long? Okay, I don't know why it did that. I'll just terminate that and run the program again. Okay, so there we go. So first we call cat1.eat and it goes nom nom nom. Okay, dan.eat goes nom nom nom. Bingo.eat goes nom nom nom. Okay, so the eat method, as you can see, is shared among the three different classes of animals. Okay, there's the human, the cat, and the dog. This was the cat, this was the human, and this was the dog. Okay, however, notice what happens with the speak method. Okay, the speak method is different across the three different classes. So the cat goes meow, the human goes just a bunch of gibberish because you forgot about Dre, and the dog goes woof woof woof. Okay, so that's how the abstract method works. I think just to show you some other maybe importance of actually implementing it this way, I would show you that okay, to do that, let's change the form. Remember polymorphism. Let's change the form of the cat, the human, and the dog, and you'll see that there's no difference. So what I mean by changing the form is, let's after creating cat1, dan, and bingo, let's do this. Let's say animal. Remember, because a cat is an animal, you can actually store a cat inside an animal type. Okay, so we're going to say animal, animal 1 is equal to cat1. Okay, and then okay, let's remove all that. We're going to say animal animal 2 is equal to dan, and animal let's say animal 3 is equal to bingo. Okay, all right, so what I've just done is I've taken, you see here, we created these objects. We created a cat and we stored it inside cat1, and it's in the form of a cat, right? We created a human, we stored that human inside dan, and it's in the form of a human. We created a dog, stored it inside bingo variable, and it's in the form of a dog. Now I took those three different animals and I changed their form to be the form of an animal. So that cat we created is the same cat here, but it's in the form of an animal. Okay, Dan is in the form of an animal. Sorry, the human we created is now in the form of an animal, and the dog we created is now in the form of an animal. Notice that because we implemented it this way, we can actually do everything the way we did it initially, and there should be no problem. So what I mean is, we can say animal1.eat. Okay, we can ask that animal to eat. We can ask animal2.eat. Okay, we can ask animal animal3.eat. Okay. Also, we can say animal1.speak. Now, this is the power of that abstract member, that abstract speak member that we created inside animal. Notice that we're using this animal. We're using it as if we're using the animal one is a cat. We're using the cat as if it is an animal, okay, as if it is in the form of an animal. But because this speak method exists, okay, it exists inside the animal class, okay, you can still call the speak method, okay. Let's just finish this animal2.speak and animal3.speak. I hope this makes sense to you. Okay, if I run this, we're going to see that it works exactly the way we expect it to work. Okay, you can see nom 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 nom, meow, gibberish, woof woof woof. Okay, now this is the true power of that abstract class. Because okay, maybe I should just show you, and maybe I should try to practicalize it for you. If we go into the animal class, what I'm saying, what I keep stressing is that is the reason why we made this abstract. Imagine if we made this say this speak. Suppose we do not make it abstract. Suppose we make it a void method or virtual method. Okay, yeah, let's go ahead and make this a virtual method. Okay, so we go public virtual void speak. Okay, no, not virtual. Let's say we make it a normal method. Okay, public void speak. Okay, and we remember here we created different implementations of the speak, so we have to remove these override. Okay, I see the problem we can run into. Okay, let's just go ahead and remove these override. Okay, override, remove this, and we remove this. Okay, public voice speak. Okay, so it's now happy. Yeah, I just want to show you what happens if we had implemented it this way. Okay, so imagine if we implemented speak this way, and then we say to speak, for an animal to speak. Notice even here you're going to have problems, like what should the animal say? Like, oh, okay, you don't know if the animal is going to be a dog, or is going to be a cat, or is going to be a human, right? So okay, so for that, let's say console dot right line. Let's just leave this to be 3 dots. Okay, like you can see already you have problems in, like, you don't know what you're going to write in here, because the animal can be a dog, the animal can be a human, and the animal can be a cat. So already you have doubts on what you should implement in here. Okay, you can see what I'm trying to show is the reason why we're making that speak method abstract. Okay, now notice if we run this program the way it is. So let's go to program class. See, so we created a cat, a human, and a dog, and we first we put them in the form of animal, and we call this speak method. We call the eat method, and we call the speak method. Notice what happens. Okay, so you can see they share the speak method, even though you actually created different speak methods here. Okay, the speak methods that you create inside here does not get accounted for, because remember this is a normal speak method. Okay, so that's why we're making this abstract, and we go ahead and we override in the, I hope that makes sense, and we go ahead and we override in by the way, if you make a method abstract, it means you do not create implementations for it. Okay, and we go in here and we override speak. Override should be before void. Okay, and we do the same thing here. We put our override, and we come in here and we put our override. Okay, so that is what abstract methods and abstract classes are all about. Okay, I hope that makes sense to you. If it doesn't, I know my explanation probably isn't the best. You should probably look up other explanations of abstract classes and abstract members. Okay, all right, so I'll see you in the next class.